So the next topic is going to be trigonometric substitutions. A special kind of substitutions using trigonometric functions that you do when you see square roots. But essentially, in that topic of trigonometric substitutions, and that's something you cannot read easily in the textbook, there are essentially two steps. One step is transforming a quadratic formula into one of three very special forms. And that transformation can be always done using linear substitutions, maybe several times. And that's exactly the thing that has no calculus involved, and I will do it today. And that's called completing squares. And then, once you are done with that step, and you reduced any quadratic formula into very special, one of the special forms, then by looking at those forms, you recognize one of the trigonometric identities, and according to that identity, you make a substitution. And that's it. And once you make a substitution, the integrand transforms into something trigonometric, and then you finish computing trigonometry. So, I will focus now on this operation that you should have learned years ago, right? And it's basically about expressions like 3x squared minus 2x plus 5. And completing square here. What do I mean by completing square? I mean writing this as a square of something, that something should contain the variable x, and possibly plus a constant. So my goal is to make that a square and to hide the constant inside. And of course, sometimes you can do it easily, right? X squared plus 2x plus 1 equals, can you complete the square? X plus 1 squared. Very good. And x squared plus 2x plus 2 equals, can you complete the square? As easy as the previous one, exactly. It's x plus 1 squared, but not exactly, right? I allow that constant to hang around. Alright, so, okay. X squared plus 4x plus 7. Can you do that? X plus 2 squared plus or minus what?
Plus 3.
Plus 3. So now think about how do you do that? Can you do x squared plus bx plus c? Can you do it in general? X plus what? Is that what you... No, it's not c, right? It's b over 2. Isn't that what you do here? Right? You take this number, divide by 2, put there. So x plus b over 2 squared plus what? Who knows? But
it's a difference, c.
Just a difference, yes. Plus c minus b squared over 4. Right? Whatever that is, this all is a constant. Okay, well, you can work out pretty general expression. The only case left is when you have coefficient with x squared. So let's do ax squared plus bx plus c. How would you complete a square there? Well, I suggest you factor a to begin with. You can always do it. A times x squared plus b over a x plus c over a. Now, can you complete square inside? Well, sure you can. You just did it, right? So what's the square? Yes, that's exactly what it is. X plus b over 2a all squared. And then the constant is going to be c over a to begin with, minus whatever the square I artificially added there. Minus b squared over 4a. Squared, yes. I'm just thinking about writing that a little differently. B squared over 2a squared. Okay. And then, well, the whole thing becomes, what does it become? A times x plus b over 2a squared. I'm just multiplying by a through the whole thing. And when I multiply by a, I'd like to bring this term to the common denominator. So I will have plus, and my common denominator will be 2a squared, right? And if I do that, I will have to do what? C has to be multiplied by something, right? 4ac minus b squared. You see some familiar things showing up? Quadratic formula shows up, right? Because you see, it is probably hard to solve this equation from scratch if you don't know the formula, right? But you can do this equation if you make it equal to 0. Can you solve for x in this equation? Well, there is only one appearance of x right there, right? And to solve for it, you just take that to the right, divide by a, take a square root, subtract b over 2a. Right? So let me solve for x. I will take this to the right, and it will become 4. Well, if I take it to the right, it gains negative sign, so you have b squared minus 4ac, all divided by 2a squared.
You have to distribute
yes, I forgot to distribute a. So I have to multiply that by a, and that makes my denominator 4a instead of 4a squared. 1a cancels. Okay, now I have to divide by a. Right? So x plus b over 2a squared is equal to b squared minus 4ac over 4a squared. Now I have to extract the square root. X plus b over 2a equals square root of all that. Well, I can extract square root in denominator, right? So it's something divided by 2a. And remember, we have to divide by 2a. And numerator is that square root of b squared minus 4ac. And that's exactly the step that you can do sometimes, but not always, right? This is the only step in the whole thing that fails if that number is negative. You cannot take the square root. And then what do? Well, I take this term to the right. So x is, there's something I forgot this here. What did I forget? Plus minus, that's right. You're paying careful attention. So x is equal to negative b over 2a plus or minus square root of b squared minus 4ac over 2a. Same to a. So I have common denominator. So x is negative b plus minus square root of b squared minus 4ac divided by 2a. That's cool, right? Well, you see, the amazing thing here is that in the whole process, there is one single idea, right? The rest is technicality. The rest is, just juggling those left and right and dividing and taking square root. So the one single idea is that you can take this quadratic expression and you complete the square. Once you completed the square, your variable is isolated there, and you can solve for it. I wish you all learned that idea, one idea, back then in school. But we will have to use it several times. And, well, this will be essentially the preliminary step for integration. Whenever you see square root of something like 3x squared minus 5x plus 5, you will have to complete the square there first. You will have to bring it to the form square root of 3 times something squared, well, or rather just something squared plus a constant, and you will go from there. But essentially, that's, I believe, the deficiency of the current education, in the sense that you don't learn the ideas. You learn the tricks, the formulas, the answers. Right? So that's an example of what I would like you to learn in this class. Right? The ideas, mainly. And your ability to explain using ideas. Because it is easy to explain the whole process at the level of idea. The main idea is here, and the rest is, well, whatever you see, you just do.